In today's class, we will learn about problems on Fourier series. In this, we'll see one of the remark. That remark says how to find Fourier series of discontinuous function. How to check even and odd function of discontinuous. So one of the problem we'll see here as obtain the Fourier series of the function f of x is equal to x in the interval 0 to pi and 2 pi minus x in the interval pi to 2 pi.
Hello students, we'll see the problems on Fourier series. So before starting a problem, we'll see one of the important remark. What is that? We'll see now. If function f of s is discontinuous, so which kind of we'll see. So it is nothing but function f of x is equal to phi of x in the interval x greater than 0 less than pi, and another function f of x is equal to psi of x in the interval x greater than pi but less than 2 pi. Then how to check for such kind of function whether it is even or odd or general, we'll see now. So we say that f of x is even if so it is 0 to 2 pi, then x will be replaced by f of 2 pi minus x if the result tends to what here, psi of x. If after replacing x by 2 pi minus x, if we replace x by 2 pi minus x and that function turns to what here, another function psi of x, then we call it is phi of. In phi of x, if you replace 2 pi minus x, we'll get what here, if you're getting a psi of x, then we call it is even, and f of x is odd. F of x is odd if psi of 2 pi minus x if turns to minus psi of x. So we need to check. So we have two functions, phi of x and psi of x. So on replacing in the interval 0 2 pi, if it is there, if 0 2 pi is there, we have to replace x by what here, 2 pi minus x. So on replacement of x by 2 pi minus x, if the answer turning to plus psi of x, at that time we can say it is even. If it is minus psi of x, then we call it is what here, odd function. And if it is neither turning to a positive psi of x or negative psi of x, some other function only, then we can, it is called as what here, general function. This is for period 0 to 2 pi, and we have similar period, which one as if f of x is equal to, if f of x is equal to psi of x in x greater than 0 less than L, and phi of x in x greater than 0 less than L, and psi of x in x greater than L but less than 2L, then we say that f of x is even if phi of 2l, because period is 2l minus x is equal to psi of x, even function, and f of x is odd, f of x is odd if phi of 2l minus x is equal to minus times psi of x. The same, only instead of pi we have L. So here while solving we need to first calculate what is the value of L, then we need to apply here. So this is for a period 0 to 2 pi and 0 to 2L. But in case if it is minus L to plus L, so at that time x will be replaced by minus x in both the cases, for minus pi to plus pi and for minus L to plus L if the interval is there at that time. So here x will be replaced by minus x, and if it is turning to plus psi of x, at that time it will be even, and if it is minus psi of x it will be odd, and if it is not turning any of the case, then we call it is general function. So based on this we'll see the examples now, how this discontinuous function is going to be solved using this condition under this Fourier series. So how to solve the Fourier series of this discontinuous function, we'll see with the help of this remark now. The problem is obtain the Fourier series expansion of the function f of x is equal to x, where the interval is x greater than or equal to 0 and less than or equal to pi, and another function 2 pi minus x, where x is greater than or equal to pi and less than or equal to 2 pi. So solution: so you need to first collect the given function, that is f of x is equal to, we have what here, x in the interval x greater than or equal to 0 and less than or equal to pi, and another function 2 pi minus x for this x greater than or equal to pi and less than or equal to 2 pi. So we have two intervals here, one is 0 to pi, another is what here, pi to 2 pi. So for 0 to pi we have x, and for pi to 2 pi we have 2 pi minus x. So with the help of this, so for this, so first function, I will consider, let phi of x is equal to x as per the note, okay, as per the remark. So this I will consider a place out here, phi of x is equal to x, and 2 pi minus x, 2 pi so psi of x is equal to what here, 2 pi minus x. So we have considered two cases. So interval is 0 to 2 pi. So replace, we'll check for the even and odd, replace x by 2 pi minus x. So where we need to replace, in phi of x, we'll see what we'll get. So after replacing, if answer is turning 2 pi minus x, at that time we'll see what happens. So on replacing x by 2 pi minus x in phi of x, what happens? So phi of 2 pi minus x is equal to, so x will be replaced by what here, 2 pi minus x. But this 2 pi minus, after replacing we are getting, this is nothing but the answer of what here, psi of x. So I can say that, so therefore f phi of x is even. So which implies f of x is even. If it is even, what happens, the condition for Fourier series, if function is even, I can say that the Fourier coefficient Bn will become 0. If it is Bn it will become 0, then the Fourier series of period 2 pi is given by, the Fourier series of period 2 pi is given by what here, if it is even. So as we know, it is f of x is equal to a naught upon 2 plus summation n from 1 to infinity an into cos of nx. So this is our equation number 1 now. So in this equation number 1, we'll find the value of a naught, we'll find the value of an, where a naught is given by, so this is even function, a naught is given by 2 upon pi 0 to pi f of x dx. This is the a naught value, and an value is given by, an is nothing but 2 upon pi 0 to pi f of x into cos of nx into dx. So remember, so even formula for this. So at that time 0 to pi means, for 0 to pi what is the function here? Only x. So this will be neglected because it is 0 to pi, we have the integrals here. So in both the cases 0 to pi, so function f of x will be what here? X. So therefore we need to calculate a naught and an. So these two values will substitute in the equation number 1, then we'll complete our Fourier series. So we'll see the value of a naught now. Now a naught is nothing but 2 upon pi integration 0 to pi. For 0 to pi, the function f of x is x and into dx. So that is 2 upon pi. So integration of x is x square upon 2. So this 2 you take outside, 2 upon 2 into pi up, and the limit from 0 to pi here. So apply upper limit, it will be pi square. Apply lower limit, it will be 0 square. So 2 cancels. So a naught is equal to pi square upon pi, or a naught is equal to 1 pi cancels. So a naught is equal to how much here? Pi. So we got the value of a naught. So with the help of this a naught, we'll go for the next value of our Fourier constants, that is an is nothing but 2 upon pi integration 0 to pi, function f of x is what here? X, and we have cos of nx dx. So for these two we need to apply Bernoulli's. So on applying Bernoulli's, or I can say that applying Bernoulli's rule, a naught an is equal to 2 upon pi as it is, u and v. So in this we'll keep u as it is. Integration of cos nx is nothing but sine of nx divided by n, formula minus differentiation of, sorry, this is x here, this is x, so we'll keep x as it is. So integration of cos nx is sine nx upon n. Differentiation of x with respect to x is what here? 1 upon n you need to carry. So integration of sine nx is what here? Minus cos nx divided by n. Differentiation of our u function, that is differentiation of 1 is 0. So we'll stop it and conclude as what here? The limit 0 to pi. So once we apply, so I can say that if you apply upper limit for the sine function, replace x by what here? Pi. So it will become what here? Sine n pi. Sine n pi is 0. If you replace lower limit for this function, sine of 0 is 0. So if you apply upper and lower limit, so this vanish directly. So left part I will rearrange first, then we'll apply the limit. So an is equal to this 2 upon pi as it is. So minus minus plus. So we have left inside what here? Cos of nx divided by n into n is what here? N square, from 0 to pi. 1 upon n square you take outside. So 2 upon n square pi. Apply upper limit. Cos of n pi minus x will be replaced by 0. It will become cos of 0. So on final simplification, so an is equal to 2 upon n square pi. Cos n pi is nothing but minus 1 raised to n. Cos 0 is 1. So I can say that, so this is the required value of our an. So which one we are going to apply in the equation number 1. So equation 1 becomes that is our Fourier series. So that is f of x is equal to a naught value. A naught value is, we got pi, and in the formula we have already 2 divided by 2 plus summation n from 1 to infinity a n value. So a n value is 2 into minus 1 raised to n minus 1 divided by n square pi into cos of nx. So this is the required Fourier series of the given discontinuous function.